All right, so we skipped this yesterday because yesterday we were just focusing on identifying what type of quadrilateral we had. But today we're going to actually talk about this specific type, finding the perimeter. So you might be asked to find the perimeter of a rectangle or any really quadrilateral, but also of a triangle. Okay, so this is page 36. So the first thing that we're going to do is plot our points. Let's graph this triangle. -4, -2. And I'm going to call that point P. -1, -6. And I'm going to label that point Q. Pencils, what are you looking for? It's in the student center, all the way over, the green and yellow drawers. They're labeled. And then R is 6, -3. Okay, so I am going to plot my points and connect my lines. So someone tell me, what does perimeter mean? Yeah, add up the sides. That's exactly what it means. It means add up the sides. So if we're going to add up the sides, what do we need to find? If we're going to try and add up the sides, what do we need to find of each side? This is page 36. Page 36. What do we need to find? The length. Yeah. How do we find the length of something, Ken? What do we really do? We call it the length, but what formula are we using? Did you say it? What do you think? What formula are we using to find the length of the sides? What formula is that? Say again, Jerry. Is it a midpoint? Does the midpoint tell me the length? Does the slope tell me the length? No. What's the formula that goes under the square root symbols? Nice and long. The distance, yeah. So we have to find the distance of each side. So let's find the distance of PQ first. The distance of PQ. Okay, so let's see. I'm going to go from P to Q. So the square root of x coordinates, -4 minus -1. Minus a negative makes it plus the quantity squared. Plus the y coordinates, -2 minus a -6. -2 minus a negative makes it plus the quantity squared. So -4 plus 1 is anyone? -3. So I have -3 squared plus -2 plus 6, anyone? 4, quantity squared. So what is -3 when I square it? -3 times -3 is +9. +4 times +4 is 9 plus 16 is, and what is the square root of 25? So I'm going to label that in my drawing. This is 5 units. This is 5 units. For those of you that I typically give filled out notes, I'll make a copy of these. Now let's find the distance of QR. Let's find the distance of segment QR. Q to R. X is first. -1 minus 6. Quantity squared. Plus -6 minus a -3. Minus a negative makes it plus. So let's see. What is -1 minus 6? Pick up your pencil. Come on, let's go. -7. Quantity squared. What is negative 6 plus 3? Can you see that better? Negative 3, the quantity squared. What is negative 7 when I square it? Positive 49. What is negative 3 when I square it? What is 49 plus 9? 58. What is the square root of 58 about? The square root of 58 is about, there are a couple of calculators out there. About 7.6. So I'm going to go to segment QR and I'm going to label it 7.6. Okay, let's talk about the distance of RP. The distance of RP. So I'm going to go from segment R to segment P, or from point R to point P. So R, 6 minus a negative 4. That's my x coordinate. 6 minus a negative becomes plus 4, the quantity squared, plus negative 3 minus a negative 2. Negative 3 minus a negative becomes plus 2, the quantity squared. So let's see, what is 6 plus 4? That gives me 10 squared. And negative 3 plus 2 is negative 1 squared. 10 squared is 100, and negative 1 squared is 1. So this equals the square root of 101, which is about 10 point. Isn't it just 10.0? Yeah. So we're just going to write 10.0. We're finding the perimeter of this shape. We're finding the perimeter of this. So we have to add up all the sides. The perimeter, 5 plus 7.6 plus 10. So the perimeter is about what? Jerry? Yeah, it's about 22.6 units. I'm going to leave that there for a second. Everyone has it written down. Braden, are you writing this down for me? Or are you boycotting me? Oh, you're boycotting me? Okay, we'll write this down. The next page that we're going to jump to is page 41. We're going to jump to page 41, okay? Got it, Braden? So page 41 says, finding the area of polygons using the coordinate plane. Finding the area of polygons using the coordinate plane. So example number 1, we're going to graph the set of points and find the area of triangle ABC. So this is on page 41. Number 1, point A is the ordered pair negative 3, positive 1. Go ahead and plot that point. Negative 3, positive 1. Point B is the ordered pair 1, 6. Plot that point and label it. And point C is the ordered pair 5, 1. So this is actually a really nice problem for us to start off with. So how do I find the area of a triangle? It is, exactly. It's the base times the height divided by 2. And I want to tell you something about the base and the height. The base is always perpendicular to the height. The base is always perpendicular to the height. So the cool thing about this question is that this triangle has a horizontal that we can use as the what? What can that measure represent? Yeah, this can be our base. So let's count. What is the measurement of our base? 1, 2, 3, 4, 5, 6, 7, 8. So our base has a measurement of 8 units. Let's think about the height. If I were to, it's called drop a perpendicular, right? From this top vertex, if I were to draw a straight line coming down, what do we know about vertical and horizontal lines? They are what to each other? They're perpendicular. So this is going to be my height. That line that we just drew is going to represent our height. How many units is that? 1, 2, 3, 4, 5. So our height is 5 units. So we're just going to take those two numbers and plug them into our formula. Our base times our height divided by 2. That gives me 40 over 2, which equals 20 square units. Area is squared. So this has an area of 20 square units. Good with that? We all have that filled in? Okay. Can I go on, or are we still working on this one? Raise your hand if you need more time. Okay. Number 2. Number 2 is a quadrilateral. It has vertices D, E, F, G. So we need to plot those vertices. D, 6, 1. E, 2, 4. F, -5, 4. And G, -1, 1. I saw some of your work last night. Some of you guys are not connecting your ordered pairs in the order that they're given. So this is D, E, F, G. I saw some like zigzaggedy little lines. You have to make sure that when you connect your points, you go in the order that they're provided. Okay. So identify what type of quadrilateral this is. So what type of quadrilateral is this? It's what? It is a parallelogram. It doesn't say prove, it just says identify it. If we had to prove it, we could find the slope 0, slope 0, slope, let's see, down 1, 2, 3 over 1, 2, 3, 4, down 1, 2, 3 over 1, 2, 3, 4. So we could show that they're slopes on opposite sides are the same. But again, it doesn't say to prove it. So it says to calculate the area. Well, I need to know the formula first. How do I find the area of a parallelogram? Area of a parallelogram. Do you guys remember learning that? You don't remember what it is? It's a lot like the area of a rectangle. I mean, a parallelogram is just a rectangle that someone like sat on and did what with the sides? They like smushed it, right? So if you think about a parallelogram, if it was a rectangle, you would take the length times the width, right? Or the base times the height. So when I squish it, this isn't how, like, this doesn't represent how tall it is anymore. So if I have my rectangle and I squish it over to the side, this represents how tall it is. So if you look at that picture, you still have a base. So the formula for the area of a parallelogram is just the base times the height. So let's let this measure represent our base. And remember, we said that our base and our height are perpendicular to each other. So we just have to draw a perpendicular line that represents the height. So I can put it here. I can put it here. Either one of those represent your height. Either one of those drawings can represent your height. Both of those are perpendicular to the base, and both of them show how high your parallelogram goes. Remember that the base and the height have to be perpendicular to each other. And the cool thing about it is the orientation is good, so I don't have to do any real measurements. The orientation is nice that I can just count. So what is the measurement of our base? Yeah, our base has a measurement of 7. And what is the measurement of our height? 3. So this has an area of 21 square units. Now, the next question is not as easy. It asks me to calculate the perimeter. Perimeter is adding up the sides, right, on the outside. So I know that the opposite sides of a parallelogram are congruent. So if this has a measurement of 7, then this also has a measurement of 7. But I have to figure out these sides. So you get a choice. You get to do it one of two ways. You can either use the distance formula, or you could turn it into a right triangle and use Pythagorean theorem. Which method do you like better? What do you feel more comfortable with? Eleni, you shouldn't be on your computer right now. You're not typing. What method do you like better? Pythagorean theorem. Okay. So this leg has a measure of 3, and this leg has a measure of 4. So if we're trying to find C, the hypotenuse, we could say that 3 squared plus 4 squared equals C squared. Well, that's 9 plus 16 equals C squared. 25 equals C squared. When I take the square root of both sides, I find out that C equals 5. So this side right here has a measure of 5, and this side has a measure of 5. Because opposite sides of a parallelogram are congruent. So the perimeter is 7 plus 5 plus 7 plus 5, which equals 24 units. What do you think about that? So honestly, when I have a graph, when I have a graph that I can visually like draw on, I think that I probably always use Pythagorean theorem over the distance formula. Just because I like it better, I don't know. I just feel like it's so much quicker. And maybe it's not. Maybe that's just my brain, but I really do feel like it's just faster. So you can use, right? If you can draw on it and turn it into a right triangle, you can use the Pythagorean theorem in lieu of the distance formula, because remember, the distance formula came from the Pythagorean theorem. Okay. Raise your hand if you need more time on that one. Okay. So some figures have to be subdivided into smaller regions that form common shapes that we know formulas for, right? So we have this polygon and it has 6 vertices because there are 6 letters. So let's graph this and see if we can figure out what kind of shape we're going to turn these little, this polygon into. So 1, 2, 3. So point A is the ordered pair 4, 0. Point B is the ordered pair 3, 3. Point C is the ordered pair -1, 3. Point D is the ordered pair -4. Point E is the ordered pair -1, -3. And point F is the ordered pair 1, 2, 3, 3, -3. So A, B, C, D, E, F, back to A. So we're only finding the area, not the perimeter. We're only finding the area of this shape, not the perimeter. Maybe pick your head up. So what kind of shapes do you guys see there? What do you think you can turn it into? Two triangles and what would be in the middle? A rectangle. Yeah, we can do that. So tell me if this is what you're thinking. A triangle here. A triangle here. And then this rectangle in the middle. Does that work okay for everybody? Yeah, is that what you were thinking? Okay. So let's talk about the rectangle first. Because that's going to be the easiest one. Area of the rectangle. So if we add up the area of the smaller pieces and we just add them all together, that'll give us the area of the whole thing, correct? So area of the rectangle, that's just length times width. So 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6. 24 square units. And I heard you say that. Rylan, I was just trying to count it out. You were ahead of me. So 24 square units. So let's go to the yellow triangle next. I know it looks orange on the screen, but I promise you it's yellow on mine. So let's do this, the area of this triangle that's yellow. So do we know the base of the triangle? It's 6. Can we figure out the height of the triangle? Yeah. Let's draw a little perpendicular in there. So this height is 3. So the area of a triangle, remember, is the base times the height divided by 2. My base is 6. My height is 3 divided by 2 equals what? Anyone? Yep, 9 square units. Now we're going to go to the area of the pink triangle. Find the area of the pink triangle. Okay. So the base of this is also 6. And the height of this triangle is what? Yeah, it just has a height of 1. So base times height divided by 2 has a base of 6 and a height of 1. What is my area there? 3 square units. So what is the area of the entire shape? What's the area of the entire shape? Yeah, the area of A, B, C, E, sorry, D, E, F equals 36 square units. Equals 36 square units. Do you guys feel okay with that one? 2 more examples on the back. 2 more examples on the back. Flip over. So we're going to calculate the area of another irregular shape. And sometimes it may be necessary to surround your figure with a rectangle and subtract the area from the outside of the graph polygon. So let's find the area of triangle ABC. So let's plot our points first. So 1, 3, A, 5, 2 is B, and -1, 2, 3, -1, 2, 3. And -3, 3 is C. So my triangle looks like this. And there are no horizontal or vertical lines here that we can count. And there's not even a line that we would know how to draw for a perpendicular, right? We wouldn't even really have an option to put a perpendicular in here. So here's what we're going to do. We're going to turn this into a rectangle. So I'm going to encompass the whole shape. I'm going to encompass the whole shape in a rectangle. And we're going to subtract out the highlighted areas that are really not part of this triangle. But we're going to be able to calculate those areas quickly because they are horizontal and vertical lines, meaning they're perpendicular. So we have an area of the base and the height. So I'm going to label these as triangle 1, triangle 2, and this teeny little guy right up here is going to be triangle 3. So let's figure out the area of the rectangle first. So we're going to take the area of the rectangle, just so you know, and from it we're going to subtract the area of triangle 1 plus the area of triangle 2 plus the area of triangle 3. So that's really what we have, a rectangle minus those yellow shapes. Okay, is everybody with me on that? Does that make sense? So if I wanted to figure out the area of the rectangle, again, we just have some horizontal and vertical lines. So my length, 1, 2, 3, 4, 5, 6, 7, 8, times my width, 1, 2, 3, 4, 5, 6. So what is the area of the rectangle? 48 square units. Yes, sir. Let's find the area of triangle number 1. So triangle number 1, notice that these horizontal and vertical lines make a perpendicular right here. So we could say that the base is 1, 2, 3, 4 units. So my base is 4 units. And my height is 1, 2, 3, 4, 5, 6 units. 4 times 6 divided by 2 is 12 units. So 12 square units. Let's find the area of triangle 2. These are my favorite kind of questions. So base times height divided by 2. So the base, 1, 2, this is perpendicular to each other, right? So 1, 2, 3, 4, 5, 6, 7, 8. My base measurement is 8. My height measurement here, 1, 2, 3, 4, 5. 8 times 5 divided by 2 is, what is 8 times 5? 40 divided by 2 is 20, yeah. So this gives me 20 square units. My last one, area of triangle 3, that's just a baby little triangle over there. Base times height divided by 2. So the base measurement, I'm going to say, is 1. The base is 1. And the height is 1, 2, 3, 4. 1 times 4 is 4, divided by 2 is 2 square units. So the area of the shape is 48 square units. That's my rectangle, minus the sum of the area of the triangles, 12 plus 20 plus 2. So that equals 48 minus 34. And 48 minus 34 is 14 square units. So that little teeny triangle has an, well, that the non-yellow has an area of 14 square units. My OneNote's trying to have a heart attack, but we're not going to let it. We're going to make it keep on going. Last example. So this quadrilateral has vertices. Whoa. There you go. 1, 4. Call that A. B is the ordered pair 2, 3. C is the ordered pair 0, -3. And D is the ordered pair -3, 1. So this, God bless you, looks like this. Again, we want to turn this into what shape? Yeah, we want to turn it into, actually, if we turn it into a rectangle, it should be pretty quick. Let's turn it into a rectangle. So this is my rectangle in pink. So let's figure out the area of the rectangle first. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7. So length times width. 5 times 7 is 35 square units. Now this time we have 4 little triangles that we have to get rid of. We have 4 little triangles that we have to eliminate from our rectangle. So I'm going to try and change a color and label those if it's going to let us. There we go. So I'm going to call this triangle 1, triangle 2, triangle 3, and triangle 4. So area of triangle 1. So what's the measure of the base? 1 times the height divided by 2 equals 1/2. So this is half of a square unit. This is triangle 1. What about triangle 2? Has a base of 3, height of 4. So area of triangle 2, 3 times 4 divided by 2 equals 6 square units. Area of triangle 3. So let's see, 1, 2, 3, 4. 1, 2, 3. 4 times 3 divided by 2 is also 6 square units. And triangle 4 has a base of 2 and a height of 6. 2 times 6 divided by 2 is 6. So the area of the whole shape, 35, minus the area of 6 plus 6 plus 6 plus 1/2. Well, that's 35 minus 18.5. 16.5 square units. So again, these are my favorite type when we have to like turn them into a rectangle. I just think it's cool.